This is the Master Brewers Podcast, brought to you by the Master Brewers Association of the Americas, a volunteer organization dedicated to continually improving the products and processes of our membership since 1887.
Let's go!
Master Brewers brings you interviews with the industry's best and brightest in brewing science, technology, and operations.
Calm down, I'm moving too fast.
This Master Brewers podcast is proudly sponsored by Hopsteiner, a global leader in the hop industry focused on quality, sustainability, and innovation in new hop varieties and hop products. Contact our brewery sales team to provide you with the hop-related tools you need to craft your next great beer. For more information, visit hopsteiner.com.
Additional support provided by
Draft Lab knows that quality and consistency are your brewery's top priorities. Draft Lab provides easy-to-use sensory analysis tools designed to bring your tasting data into action. To start your free 2-week trial today, visit draftlab.com. That's DRAUGHT lab.com.
It's important to think about how you use your hops instead of how much hops you put into the beer.
This week on the show, a dry hopping study that really knocks it out of the park. Maria and Will from Sierra Nevada are here to walk us through their work and to help you make better beer.
We really pulled together a lot of research from different individual papers, and we kind of put it all into like one study. Whereas some papers might have just looked at, the dry hopping effect on biotransformation, and we added that with a physical stability component and the elemental analysis, and really tied it all together to get really great understanding of dry hopping.
What were you trying to determine?
We were looking at trying to understand if we could modulate flavor profile of our different beers or different brands based off of solely dry hopping at different times during fermentation.
Yeah, we were really interested to see if increasing the time that hops spent in the presence of yeast could promote different flavors. We're a company that uses whole cone hops, and we have many wonderful hop-forward beers. And being able to modulate flavor with dry hopping time could really give us an opportunity to expand on brand potential and flavor potential.
We were also looking to see if dry hopping at different times was impacting physical stability in the brands. There's been a lot of talk in the brewing industry on whether or not dry hopping early in fermentation increases haze or haze potential, and whether that's important for New England style IPAs or not.
Okay, so the bottom line here is, can we develop new brands while basically using the same hops, right?
Yep, absolutely. So being able to use the same essentially recipe, but modulating hopping time to promote different flavors is something that's really interesting and potentially unique. And that's definitely something we were looking for.
Is it safe to assume you ran these trials in the pilot brewery in Chico?
No, we actually did this trial in our nano brewery. So we have about a half barrel or 15-gallon kind of very advanced home brewing kind of setup in the nano with temperature controlled fermenters, and it's kind of separate from our pilot brewery, but it's kind of an R&D type brewery, small scale, but before the pilot.
Okay.
Yeah, and it's particularly important that we use the nano in the study because we were able to pull wort from production. So from the same pump-in, same recipe, same raw materials, we were able to siphon off that wort into 4 of these nano fermenters, meaning that we started off with the same base recipe, potentially eliminating any variables if we were to brew these individually, with respect to brewing and kettle hop or whirlpool hop additions. We eliminated any of those variables by being able to use the same production wort.
I like it. So tell us about, how you set this up when you added hops for the different trials.
Yeah, so we had 4 different trials. The first one being a control that didn't receive any dry hopping at all. The second test, or I guess the first test, would have been fermenter full. So at day 0, as soon as the wort was pumped into the fermenter, we added 150 grams of Cascade hops, whole cone. The second test was when we added our hops warm to cold, and that was approximately, it was day 4, and those hops were on the fermenter for about 3 to 4 days. And then the fermenter was chilled down to 40 degrees. And then we added hops cold, which was added on day 8, and that was at 40 degrees Fahrenheit.
Okay. So when you say warm to cold, you're just meaning that they were added during the active fermentation, and then the cooling happened after they were added, essentially, right?
Yeah, so I guess to jump in here, the warm to cold addition was added when carbohydrate utilization had ceased. So the attenuation was steady, but our VDKs hadn't dropped to our chill spec yet. So this is still in the presence of yeast. We still had yeast in suspension, but carbohydrate utilization was essentially done. So this was around 4 days into fermentation, and we just called it warm to cold, what we call it at Sierra Nevada, which means that we add hops warm and the hops stay on the beer until the tank is chilled, if that makes sense.
That does make sense. What kind of dry hop rate are we talking here?
150 grams per 15 gallons. That is 0.5 or 0.9 pounds per barrel.
Okay, cool. Do I have this right that you actually repeated this experiment several times, right?
Yeah, we repeated it 3 times. So that was actually the only variability that we had. So the only variability was the different wort that was used to pump into the fermenters. So we controlled amongst all the tests, the control was the same for each one of the tests. And then we had another set of fermenters that was referencing the control again.
Yeah, so I think the repeatability of what we incorporated in the study and the scope is kind of what makes, I think, this so impactful. So altogether, we performed 12 brews. As Will said, 3 controls altogether, and then 3 of each individual variable. And with the repeatability, not only in the data that we collected, depending on physical stability or fermentation performance, it was also important that we were able to repeat our quantitative descriptive panel analysis. So sensorially, we were able to quantify these differences, not only with a single panel, but with repeated panels and repeated tests. So I think the repeatability is something that's quite unique to this study.
That's awesome. You'd make my chemical technical analysis teacher from brewing school very proud. She used to always say one value is no value. So give a shout out to Katrin and all those VLB alumni who have that baked into their brains.
Right on.
Okay, well let's talk about what you measured in these experiments. What were you looking to measure?
Sure. I'll start off with the fermentation side of things. So we really wanted to assess if there were potential impacts on yeast physiological health by the presence of hops. So we know hops can impart toxicity to biological organisms, particularly bacteria and things like that. But there is some potential for impact on yeast as well, particularly if these hops are present at a high concentration at the very start of fermentation. So the ways that we were looking at assessing fermentation performance or yeast health was by looking at carbohydrate utilization. So that included the time for fermentation and also the rate of carbohydrate utilization, the rate of ethanol production, and then also looking at a bunch of cell characteristics. So looking at the rate of cell growth, flocculation time, and also the rate of flocculation. And using these specific metrics, particularly as we had 3 rounds, we were able to statistically assess if we had impacts on carbohydrate utilization, ethanol production, and also cell characteristics in the presence of hops.
That kind of covers sort of the, fermentation performance stuff that you wanted to measure. What were you looking for in terms of quality of beer?
Yeah, so in terms of quality of beer, we were really focusing on the organoleptic quality and the volatile profile analysis. And then we also looked into elemental analysis for any differences in metals, specifically the prooxidants, iron, manganese, and copper. And then as well as the physical stability markers that we use at the brewery to assess if a beer is stable or not stable physically.
All right, let's look into the results. Did you find any significant differences in those fermentation metrics that you talked about?
There were no significant differences in the majority or all, I guess, of the fermentation metrics, but there were some borderline significant differences found in the cell growth and flocculation metrics. So when we had hops present in the fermenter right at the start of fermentation, we had borderline influences on the growth rate, where we had a decreased growth rate, and also it took longer for the cells to begin flocculation. Of course, again, these weren't statistically significant depending on the significance that we chose, but it does look like there is some potential impact on growth and flocculation.
Any thoughts on the cause of that?
So we're speculating that there is the potential for nucleation sites. We have, a huge bag of hops in the fermenter. It provides the potential for yeast to, interact and bind and perhaps stay in suspension longer, which could influence the flocculation time, make it take longer for the cells to flock out of solution. But really, it's speculation at this point.
How about physical stability? What did you find out there?
We also found no statistical difference in any of the physical stability metrics that we were looking at. And these are total polyphenols, sensitive proteins, tannins, and a measurement called Chapone, which measures the chill haze of the beer. So this is kind of a total holistic kind of view of traditional beer haze, which kind of is very important for New England style IPAs. We were actually kind of surprised at this because there was so much talk about this in the industry and on forums and in person. We heard a lot about this, but also quite interesting that at the same conference, New Belgium also reported that the opposite of what we found. So I don't know if our metrics, and they're using the same metrics, so I don't know if our metrics aren't sensitive enough to pick out differences, or if they're not looking at what is like the correct metric that we need to be looking at to understand why hazy IPAs are hazy.
Were they using similar dose rates? And, could it just be a recipe thing?
They were using similar dose rates from my recollection, but what they were doing differently is that they were looking at a ammonia sulfate precipitation for their protein analysis, where we use a sensitive protein analysis, which looks at the protein-rich areas of the protein, which is the source for polyphenol protein binding.
Now, you guys also observed something that we've heard, Dr. May and a few other people speak about, and obviously a lot of us have noticed this, but dry hopping raised your pH. Why don't you talk about that? What'd you observe there?
Yeah, so in all cases, dry hopping increased our pH. And we found this result to be pretty interesting because nobody's really reported on it. People have talked about it, but nothing like super in depth, and wasn't any literature on the subject. So I'd say after 1 day after the dry hopping occurred, the pH raised about 0.25 units. 0.25 to 0.3 units, I'd say. And that was in all cases of dry hopping.
So to kind of expand on that, when we took a look at the pH profile during fermentation, it was really interesting to see the influence on pH depending on dry hopping time. So when, in the absence of dry hopping, our beer pH dropped from around 5.2 to 4.2, which is pretty typical. But in the fermenter full edition, we saw the pH drop to around 4.5. So the pH never actually got down to the pH of the control beer, which means that there is the potential for the hops to be acting as a buffering agent. But we also know that they're potentially contributing hydroxide ions, because if you take a look at the dry hopping in the middle of fermentation, so that's around day 4, and also the cold edition, those two beers before hops were added, the pHs got down to the control beer, so around 4.2. But upon the addition of hops, as Will was saying, the pH raised about 0.2 units. So we know that there is the potential for buffering capacity, but we also know that there's the potential for hydroxide. So there are potential two methods for either raising the pH or keeping the pH elevated above beers that don't have dry hops added.
Now, you also observed that hops actually changed your wort density. You want to talk about that?
Sure. So this is kind of an interesting and rather hot topic. In the past year or so, there's been some discussions in scientific communities about the potential for hops to contribute enzymatic activity. So contributing an enzyme that could potentially degrade dextrins into fermentable sugars, which could, of course, have some quality impacts. And what we saw in these beers is slightly different, but potentially related. So with respect to dry hopping, as hops were added to the fermenter, especially if we look at the cold edition first, all of our beers attenuated similarly. But when we added hops on the cold side, we saw an increase in the overall density. So that was about a 0.2 to 0.3 increase in Plato, which, overall may not be significant, but there was a contribution repeatedly for our cold edition hops. So that suggests that there is some density imparted from the hops. And we know that density, at least some percentage of it, is fermentable because the other dry hopped beers, so our warm edition dry hopping in the presence of yeast, we did not see that increase in density. So we know that the yeast were fermenting some of that, whatever the hops were contributing, whatever carbohydrates, the yeast were fermenting them. But universally, we did not see an over-attenuation with this dry hopping ratio of 1 pound per barrel. We didn't see any evidence of enzymatic activity, but that's not to say that it doesn't exist. It's just that perhaps at this ratio and with these hops, seeing an enzymatic degradation of wort dextrins was not visible.
Did you see any changes to VDK? I can't remember if you were measuring that throughout the process or not, but I mean, that's one of the complaints people obviously have, and we're looking at we covered this topic on episode 98 on, dry hop creep. But were you measuring that during these trials?
So we weren't measuring VDKs during fermentation. We measure VDKs as the carbohydrate utilization ceases. So as the beers are finishing up fermenting, we will take a VDK, and if it's below a certain spec, so for us particularly, it's 55 micrograms per milliliter, we will chill the beers. So unfortunately, with the cold edition, it would have been interesting, all of these beers were chilled. With respect to the warm edition, there was no influence on VDK reduction time. The control and the warm edition beers chilled around the same time. And for the cold edition, we did not actually take a VDK after we hopped. So I can't comment if the VDKs increased upon hopping. So I don't really have a good answer for that.
Okay, no, that is a good answer. And that's a good segue into talking about the sensory results. Was there any VDKs picked up during sensory?
There was no VDK picked up in our panels for any of the 3 rounds that we went through. It was not something that they picked up.
Okay, good. Well, tell us about what they did find in sensory. Coming up.
So with the same recipe, our panelists described 4 different beers.
I'm John Bryce, and you're listening to the Master Brewers Podcast from the Master Brewers Association of the Americas.
This Master Brewers Podcast is proudly sponsored by Barna Mechanical, a full-service design-build firm specializing in turnkey process and utility systems for the brewing industry. We partner with some of the best craft brewers in the U.S. to ensure the great beer they brew is what their customers get in every glass, bottle, can, or keg. You know beer. We know breweries.
Additional support provided by
ABS Commercial is a full-service brewery and parts outfitter. From our Raleigh headquarters to our Denver office, we proudly offer brew houses and fermenters from 3 barrels and up, yeast brinks, boilers, kegs, chillers, tri-clamp, and other stainless parts, all with the quickest delivery and lead times in the industry. Learn more at abs-commercial.com or call 877-BREW-ABS. ABS Commercial. We are brewers.
Here's what's coming up on the Master Brewers calendar. The first weekend in November is a real trilemma for vendor reps. District Mid-Atlantic meets at DC Brow, District Mid-South meets at New Realm in Atlanta, and District Southern California meets at Anheuser-Busch in Los Angeles. The following week is busy in Canada with the Ontario Craft Brewers Conference November 7th and 8th, and District Eastern Canada in Montreal also on the 8th. District St. Paul, Minneapolis meets November 8th at Bad Weather Brewing in St. Paul. Also in the 8th District, Northern California, is at Urban Roots Brewing and Smokehouse in Sacramento. The brand new District Northern Illinois is holding its inaugural meeting at Goose Island in Chicago, November 9th. Or if you're on the East Coast, I bet my buddy John Clegg wants to buy you a beer at District New England's fall meeting at Sebago Brewing on the same day. Just when you thought November couldn't get any busier, there's a HACCP course and a district meeting in Ontario on November 13th and 14th, and districts Milwaukee and St. Louis both meet November 15th. Check out the full calendar of events at mbaa.com for more details or to find a district meeting near you. Now back to the show. Before we could dive into sensory, we found ourselves on a bit of a tangent discussing dry hop creep from episode 98.
With that cold addition, we saw that density increase, and Maria said that likely that some of it's fermentable, and this would correspond with Allagash's study where they saw bottles exploding due to cold dry hopping and then bottle conditioning. So I think that's kind of important to talk about for the viewers, but maybe not.
But to be fair, I think Allagash, they didn't see an increase in density. So what they saw was, there wasn't an overall increase in density when they dry hopped. What they saw was a decrease in fermentable sugars, a decrease in overall dextrins. So what we're seeing here is an imparting of starch or carbohydrates from the hops, and then the subsequent decrease of that starch. Whereas with Allagash, they added dry hops and their residual density decreased. So they didn't actually see an increase in carbohydrates. If that makes sense.
I can't remember the specifics, but that packaging, if this beer was packaging and bottle conditioned, it definitely would have the potential.
That's fair.
All right, good discussion, guys. Let's move on to sensory. You guys can argue about that a little bit too. We can make for some good radio.
We looked at the 3 trials in our quantitative descriptive panel, and this uses a trained panel looking at all the different aroma characteristics of the beer. So first we defined in the first set of beers, we defined what the main characteristics of the beer were, and then the panel described how the beer is different and at what level each of those descriptors are for the individual beers. So not surprising, when we did not dry hop the beer, the cold edition, we received a lower hop intensity for that beer 3 times in a row. But interestingly, when we added the fermenter full edition, we had a very high perceived fruity and tropical fruit aroma. And followed by the warm to cold, which also had a pretty high fruity and tropical fruit aroma, but it was definitely muted compared to the fermenter full. And then that cold edition, it was statistically higher than the fermenter full and warm to cold, or statistically lower than the fermenter full and warm to cold, but it was higher than the dry hop. And this aroma is super important for, I'd say, brewers, especially right now when trying to make fruity and tropical beers, especially for New England style IPAs. So that was really awesome for us. And in my opinion, that was a very defining characteristic of each one of the beers. And then knowing that we can create such a fruity and tropical fruit aroma just because of dry hopping, I think that we kind of achieved the goals of our study when looking at sensory and aroma of the beer.
Yeah, just to kind of expand on that. So what we were able to achieve based on our QDA results is 4 statistically significant beers or statistically different beers with dry hopping time. So this fruity tropical was rated differently for each of the beers in our panel. So with the same recipe, our panelists described 4 different beers, which is pretty cool. As Will said, that was kind of the whole purpose of the study. We wanted to see, could we create 4 different beers with the same recipe? And depending on fruity tropical, we were able to achieve that. And to expand on the cold edition, historically, I think cold addition dry hopping is what's been utilized. And, with the past few years, we've moved into warm additions. But the cold addition beers were pretty surprising in terms of the negative characteristics that were coming out that our panel was able to perceive. So in particular, characteristics of burnt rubber, onion sulfur, and skunky dank in a rather negative connotation, not in the good dank. Those were all significantly higher for the cold hopped beers. In addition, caddy, so the kind of sulfur in caddy was also rated significantly higher in our cold hopped beer. So it's interesting to note that we had a lot of negative connotations coming out with the cold hopped, and we really had no positive connotations with the cold hopped beer at all. But that could be because we had these two significantly fruity rose floral beers with a fermenter full and warm to cold that our panel was just perceiving the cold addition negatively. But it's just something to note that, we did have a lot of negative associations with the cold hopped beer.
The warm to cold was a kind of a happy balance between the two of them, with some sulfur character, but more like tropical fruit type aroma in the beer as well.
That's pretty interesting. I know you haven't, or at least for this study, you hadn't run, these trials with different hop varieties. To what extent do you think that's going to be consistent across different hop varieties?
I think that every single time that you dry hop and do the study with a different beer, you're going to get a different result. I think that in general, the same trend will be seen, but all hops have different, levels of compounds in them, and that's what makes them distinguishable and how you can make different beers using a cascade and a mosaic or a citra. But the same types of descriptors might vary from hop to hop.
Okay. Anything else you want to talk about sensory, or should we hop into the next part?
Do you want to talk about how we did this with pellets, which might be relevant for other people, Maria?
We could. I guess we don't really have those results
in front of us.
So are you saying you repeated the study, but with pellets? Is that what you're saying?
We did it one time with pellets, just to kind of see what would happen, because we're a whole cone brewer, but we did do it with pellets and the results were different.
How did you even find pellets at Sierra Nevada?
We have our ways.
They're in the basement, buried.
Yeah. Tell us about that. What anything groundbreaking there?
So we don't have the results in front of us, but the one main thing that stood out to me most was that the fermenter full and the warm to cold addition were much more similar. And I can't remember how different they were, but they were not that different from each other. And we think that this is because like the increased surface area of the pellets, whereas whole cone hops, you don't have that increase in surface area.
Yeah, so for the whole cone, having those hops spend 4 more days in the fermenter for the, time zero addition may have imparted or been enough to extract or biotransform or chemically transform those compounds into flavor active compounds. Whereas with the pellets, as Will was saying, with the surface area, you don't need that extended time to extract the same flavor potential.
The pellets, you get much more extraction potential, but you don't necessarily get the same amount of same type of control that you would out of the flavor that you might want.
You also did some multivariate analysis, which listeners obviously can't see on a podcast, but how about describing any takeaways from that work?
Sure. So we perform multivariate analysis and specifically hierarchical cluster analysis. And what this looks like on the page is a heat map where colors are associated to the intensities related to, in this particular heat map, we've looked at significantly different compounds that were determined using GCMS. And then we looked at significant sensory descriptors, significant elemental analysis results, and also significant fermentation results. So anything that was significant in our previous analyses was included in this heat map. And essentially what hierarchical cluster analysis will do is it will sort all of our variables depending on their similarity to each other. And then it will also sort our beers, so our control and then our 3 beers that were dry hopped differently, depending on their similarity to each other. So it generates this map that you can kind of pinpoint similarities and differences between the beers. So it makes it visually kind of easy to look into. And what we kind of noticed from this heat map, just talking about specifically the no dry hopped, when in the absence of dry hopping, our beer had significantly higher concentrations of purans. So those are malt-derived compounds. And we also had a significantly higher sensorial rating for malty bready, which isn't surprising. But what was interesting is that our no dry hop beer, all of our fermentation esters were clustered to be higher for that beer, which is interesting. So it's either suggesting that hopping, either warm to cold, is impacting yeast and their production of esters, or causing some extraction of fermentation esters. So that was one thing that we found was interesting with the no dry hopped. And then moving into the fermenter full and the warm to cold, we had a bunch of hop-derived esters and compounds grouped closely together, and also had a higher intensity. So specifically talking about compounds that have been in the literature described to be important for dry hopping, especially with respect to chemical and biochemical transformation. So we saw an increase in ethyl-3-methylbutyrate and ethyl-2-methylbutyrate, two compounds that are quite important for that tropical fruit aroma. And these compounds are probably higher in the warm additions or the addition of hops in the presence of yeast due to either chemical or biochemical esterification of the short-chain carboxylic acid precursors. So it was great to see, some of these historically known biotransformation and chemical transformation things happening. We also saw an increase in geraniol, nerol, and linalool for our warm hopped beers. And this is probably due to the hydrolysis of geraniol and nerol esters, and also the potential biotransformation of monoterpene alcohols. And we know this is likely the case because in our cold addition beer, we saw an increase in acetate and propionate precursors to geraniol and nerol. So that likely means that those precursors were transformed in the presence of yeast or in the presence of heat into these really flavor-active compounds. So the utilization of the hierarchical cluster analysis really is able to give us an indication of trends that we're seeing with different beers. And you can also see the distinct difference depending on all of these analyses that we did between the beers. I don't know if, Will, you have anything to add?
No, that was good.
This is a tough act to follow, Will.
Yeah, it is. But when after performing the multivariate analysis, we can really start to understand how the sensory results, and we can start to deconvolute some of the sensory results and as to why we're smelling and tasting certain things. So we had increased amounts of sulfur in the cold addition, and we saw that as well in the sensory results. But we have very similar amounts of those esters that Maria was talking about, like the ethyl-2-methylbutyrate and ethyl-3-methylbutyrate in the warm to cold and fermenter full. But there was an increased sensorial amount of kind of like that sulfur, those sulfur notes. So it's not necessarily that those compounds aren't necessarily there at the same concentrations or similar concentrations. It's that they're being masked by other flavors in the beer.
Okay, so going back to those questions that you asked at the outset, you've demonstrated that dry hopping didn't affect physical stability. You also asked if we could achieve different flavor profiles with the same hop variety and concentration, and it sounds like the answer to that is a resounding yes, right?
Yeah, I mean, dry hopping time is super important for the flavor profile of your beer, and I think especially here, we've made a lot of changes into how we're thinking about dry hopping now and controlling what type of flavor profile we want based off of this work. We haven't done it with other hops, but like I was saying, the trend is kind of there, and we can for all hops, and we can start to modulate and control more of our flavor profile that we want based off of when we add our hops.
So what about developing unique brands with essentially the same hops or the same recipe, if you will? I mean, sounds like that's a pretty viable thing, right?
Yeah, the potential is definitely there. Like, depending on if you use lupulin pellets or whole cones, you can definitely make different beers with the exact same hops.
Yeah, and especially for Sierra Nevada, we're lucky we have a lot of resources available to us. If we want a hop, we're going to get a hop. But if you're a smaller brewery or even a home brewer, this can really offer you a relatively inexpensive way of making unique and different beers if you were only able to purchase, a single hop variety. So using the dry hopping time, if you only have one hop, you can theoretically make different beers and expand on your brand profiles.
I asked Maria and Will what's next, and here's what they said.
We're research and development at Sierra Nevada, so we have many pots in the fire. Just expect great things next year.
All right, I like it.
Whoa. That's we got to live up to that.
Oh, it's all in the bag, Will. Don't worry.
Oh, that's great.
This would be a really hard study to live up to because, there's been lots
Speak for yourself, Will.
Yeah, I mean, it took a lot of time, but
sounds like Maria's not a fan of under-promise, over-deliver. I don't know.
No, over-promise, over-deliver.
There you go. All right.
Happening here.
Cool.
I like to not fail.
Yeah, me too.
Will.
Maria and Will presented this work at the Brewing Summit in San Diego just a few months ago. If you want to learn more about achieving different flavor profiles with the same hop variety and concentration by modulating dry hop timing, do yourself a favor and flip through these slides. For only $89, you can have access to this presentation and all of the other amazing work that was presented at the 2018 Brewing Summit. Master Brewers members even get a discount. Go to nbaa.com/store, then click on Conference Proceedings. Hey, remember the Belgian Beer Book that Sten Mertens and Jan Stencils talked about on episode 101, The Yeasts of Tomorrow? Well, great news. It's now available in the Master Brewers bookstore. Just go to mbaa.com/store and type Belgian beer into the search bar to get your copy today.
I'm running too fast, and then I bump on the ground, where that can happen to everyone else too. Strike down, I'm moving too fast, and then I hit on the floor.
One second, I need to talk to Andrew.
Sure thing.
So we're just doing the podcast.
Does Andrew want to be on the podcast? Is he like, hey guys,
Andrew,
why can't I be on the podcast?
Actually, I just want to shout out to Andrew.
If you're just quiet, then I think we're good.
Andrew actually performed the GCMS analysis on these beers and contributed significantly to our understanding of hopping. So shout out to Andrew.
All right. Hi, Andrew.
Yeah.
Andrew, do you want to say hi to everyone?
Andrew, do you want to say hi to everyone?
All right.
Andrew is.